See, now we'll find the position of center of mass of a cone, means right circular solid cone of radius r and height h. Think how we are going to start this. Question is, you have to find the position of center of mass of right circular cone of radius r and height h. Okay, so it is A, B, C. How we are going to solve this? See, first you can find the mass of this entire solid cone. M is equals to density into volume. M is equals to density into, what is volume of a cone? 1 by 3 pi r square h. You know the mass of this entire solid cone. But to find the position of center of mass, you consider a small elementary disk of radius x and height y and thickness, let it be dy. You know how to find the position of the center of mass. YCM is equals to 1 by total mass into integration of y into dm from 0 to h. Find the dm. Dm is mass of the small elementary disk. How to find the dm? So it's equation number 1, and dm is equal to density into volume of this elementary disk. How to find the volume of the elementary disk? Here dm is mass of a small portion of this elementary disk. The dm is equal to density into volume of this small portion. Volume is area into dy, and your area is pi into x square into dy. So I'll substitute the values of m and dm in this equation. YCM is equal to 1 by mass is rho pi r square h by 3, so I'll send it to the numerator, into integration of y into dm is rho pi x square into dy from 0 to h. See, here constant terms are rho and pi. YCM is equal to 3 rho pi by rho pi r square h into integration of yx square dy from 0 to, here total height is h. So cancel rho and pi. YCM is equal to 3 by r square into h here integration of yx square dy from 0 to h. But what is this x square? X square from the triangle, okay, already we mentioned ABC, DEF. From this diagram, find the value of x in terms of h, y and r. How to find this value? See, these are the two similar triangles. ADE is similar to AFB. From two similar triangles, from two similar triangles AED and AFB. AD by AF is equal to DE by FB. What is AD here? AD value H minus Y. H minus Y by AF. What is AF? H is equal to DE. See, DE is X by what is BF? R. The value of X is R into H minus Y by H. Substitute this value in this equation. YCM is equal to 3 by R square H into integration of Y into X square is R square into H minus Y by H whole square into dy from 0 to H. See here, YCM is equal to 3 by R square H, and here R square is common, means it's a constant term. Integration of Y into, look at this, H minus Y whole square means A minus B whole square. A square plus B square minus 2HY into dy by H square. So I'll write here H cube. YCM is equals to 3 by H cube into, here limit 0 to H, integration YH square dy means Y square H square by 2 plus Y cube dy. Y cube dy integration Y to the power 4 by 4 minus 2H, again Y square into dy, Y cube by 3. So YCM is equal to 3 by H cube. Substitute the upper limit, Y to the power 4 by 2 plus, here Y is what? H. So instead of Y, I'll write the upper limit, H to the power 4 by 2 plus H to the power 4 by 4 minus 2H to the power 4 by 3. Minus lower limit is 0, so everything will be 0. YCM is equal to 3 by H cube. Here LCM 2, 4, 3 LCM is 12. So here it will be 6H to the power 4 plus 3H to the power 4 minus 8H to the power 4. So YCM is 3 by H cube into 9H to the power 4 minus 8H to the power 4, H to the power 4 by 12. So what is YCM? H by 4. So XCM, YCM, ZCM, these are the coordinates of the center of mass 0, H by 4, 0. So position of the center of mass of this cone is 0, H by 4, 0. See again, if you get any object, first you have to find mass of the elementary disk, that small portion, and then you substitute the value in the formula. If it is YCM, YCM is equals to 1 by m into integration of y into dm. XCM, 1 by m into integration of x into dm. Similarly, ZCM.